Hello everyone, I'm Ishwari Sanam, learning in grade 7 rows from Poda International School, Washim, and today we are going to learn modes of heat transfer. This is a topic from heat and its transfer. So let's see. So firstly, there are three modes by which heat is transferred. First is conduction, second is convection, and third is radiation. So firstly, conduction. So conduction, it mostly takes place in solids. What happens if you have a metal rod? Just don't try this activity. It can be dangerous. But still, as an example, if you have a metal rod, so at the time if you heat it from one end, the heat it will travel and then it will reach the other end. This is because of conduction. The molecules inside the metal rod, they cause the vibration by which the heat is transferred from one molecule to the other, and this is called conduction. Now the metals are different. So what happens? The solid, as we all know that in solid, the molecules are very tightly packed, whereas in liquid they are just they are a little loosely packed, and in gaseous state they aren't loosely or tightly packed. They are just they are just moving here and there. So insulators. So what happens? Insulators are the things that used to reduce the electricity or the heat. Like suppose wood and plastic, they are the insulators. Why? Because they do not have the sea of electrons. It means they do not have electrons, and thus they don't used to conduct heat as well as metals. So metals, they are heated because of the sea of electrons. So it means there are many electrons by which they gain the kinetic energy from the heat energy, and they then used to transfer it throughout the metal. Now, it's a question that why does metal feel colder than wood if they both are of the same temperature? Now, if on my left hand I have metal rod and on my right hand I have wood, so of course the metal would be colder. Why? Because as we all know that metal is a conductor of heat. Thus, it used to absorb all the heat from our hand, and thus it will feel cold. Whereas wood, it is an insulator, thus it doesn't used to absorb the heat away from our hands, and thus it feels warmer than the metal. What happens to the particles in a liquid or a gas when you heat them? So what happens if liquid is there? So at the time we are heating it, so what happens? It used to turn in gaseous state. So firstly, now this first image, it is liquids, and the second, it is gaseous states. What happens? The gaseous states, they are very 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 loosely packed molecules, so they used to flow here and there. So thus what happens when you heat them? These particles, they used to collide with each other, and they used to spread the heat energy, or they used to absorb the heat energy from the other particles, and then used to transfer it throughout. They move, whereas in conduction the particle doesn't move, but in convection the particles move. Where is the freezer compartment in a fridge? Of course, it is at the top. Why it is at the top? Because it has cool air, and as we all know that cool air, it sinks down, and thus it used to keep the food cool on the way down. And whereas at the bottom there is hot air, so hot air, it used to rise up till the freezer, and then it used to get cool, then again it used to sink, and this is why the freezer compartment is placed at top. Now convection. So convection is a process of heat transfer that only takes place in liquid or in gaseous state. So I would like to tell you that heat, it always transfers from hotter region to a cooler region. So what happens in this process? The particles, they change their position by constantly moving, whereas in conduction the particles don't change their position, they vibrate. But whereas in convection the molecules change their position by constantly moving, and this takes place in liquid or in gaseous states. Now, land breeze and sea breeze. Let's see what are them. Firstly, sea breeze. So sea breeze, what happens during daytime? The heat is there because of the sun. So the land, it gets heated quickly than the water, and thus water takes time to heat. So what happens? The cooler air from the water, it goes towards the land, and this air from the sea towards the land is called sea breeze. And talking about land breeze, so what happens during night? The land, it gets it gets cooled very quickly, whereas the water, it takes time. So what happens, the cool air from the land, it goes towards the sea, and this wind from and this air from land to sea is called sea breeze. It's called land breeze. How does heat energy reach from sun to the earth? So there are no mediums between, or there are no particles between that the heat can travel by conduction or convection, because as we all know that conduction or convection, they need some medium, they need particles, so they travel by radiation. So it's time to check our progress. Which of the following is not a method of heat transfer? So the answer is insulation, because we haven't learned about insulation. The next is, in which of the following are the particles closest together? So the answer is solid, because we know that they are very tightly packed. How does heat energy reach the earth from the sun? So it's called radiation, by the radiation process. Which is the best surface for reflecting heat energy? Shiny white. Which is the best surface for absorbing heat radiation? Dull black. Okay, it's the last question that we have to state whether the statements are true or false. Radiation travels in straight lines, so it is true. Radiation can travel through a vacuum, true. Radiation requires particles to travel, so it is false. Radiation travels at the speed of light, so it is true. So first is true, second is true, third is false, and fourth is true. So why are houses painted white in hot countries? So the answer is that the white, it used to reflect the heat radiation, and thus it keeps the house cool. Why are shiny foil blankets wrapped around marathon runners at the end of the race? Because the shiny metals, they used to reflect the heat radiation from the runner back in. This stops the runner getting cold. So I hope this video is useful for everyone, and I would like to meet you in the next video. Up to that time, take care and bye bye.